Okay, so we're going to be talking about multiplying some polynomials again, only this time we're going to be talking about a couple shortcuts, a couple special forms. So the first special form that we really want to talk about is how to square a binomial. Now, as you know, a binomial has two terms, and I'm just going to use a generic a plus b. Now, if I square a binomial, this is what this is going to look like. Now, note, I want you to be careful with this because I know some folks will just try to say, well, that everything is in here is going to be multiplied by itself, or this is going to be a squared plus b squared. If you do that, you're going to end up with something incorrect. Remember that the exponent means that you've got this thing, whatever's inside that set of parentheses, times itself twice. So this is going to be a plus b times a plus b. And if I were to FOIL this out, a plus a, or a times a is going to be a squared. I'll have plus ab plus another ab, and then plus b squared. So ultimately, I've got a squared plus 2ab plus b squared. And that's what this is going to end up equaling. That's the nice thing with this. This might seem like, okay, sure, I can do that every time, but I don't think you realize that this is a really, really cool shortcut. Uh, and let me, before I start to throwing out some more examples, I'm going to do this also with subtraction because it's going to be just a little bit different, not enough different, not super different, but just a little bit. So if I have a minus b squared, this of course means we've got a minus b times a minus b. A times a is a squared. It's going to be minus ab minus another ab. And negative b times negative b is also plus b squared. So when I do this, I've got a squared minus 2ab plus b squared. Notice that even though this is minus, this is still plus a b squared. It's got this minus 2ab. So the only difference between these two things is a negative. If it's plus, this is going to be plus 2ab. If it's minus, it's going to be minus 2ab. I'll pause here and let you copy down, or this would be a good place to pause and copy these down if you want. But now let's go ahead and do some examples. So let's say I've got x plus 6 squared. Now remember, we're thinking about this less in terms of x plus 6 times x plus 6 and more in terms of this a squared plus 2ab plus b squared. So we're going to be utilizing this shortcut. So this first term, our first term here is our first term squared, x squared. It's going to be 2 times x times 6, so that's going to be, well, x times 6 is 6x. I'm just going to double that, so it's going to be basically 6x plus 6x, or 12x. And then 6 times 6, 36. When you start thinking about it that way, it goes fast. Say we've got y minus 3 squared. Okay, y times y squared. Minus 3y plus another minus 3y is minus 6y. Negative 3 times negative 3 is plus 9. Done. Oh, what happens if I do 2m minus 5 squared? Okay, 2m times 2m is 4m squared. Minus 10m is going to be minus 20m. And then negative 5 times negative 5 is plus 25. So this is just a shortcut to help us go through this calculation much, much quicker. All right. Let's let's talk about what our next one. And this one is a very, very fun thing. And once you get the hang of it, this becomes this gets to be a lot of fun. This is called the product of conjugates. And a conjugate, the conjugate of a binomial is just the same two terms with the opposite sign in between them. So a plus b, the conjugate of a plus b is going to be a minus b. So these are the product of conjugates. Now, if I were to multiply these together, a times a is going to be a squared. My outside terms, I'd have minus ab. My inside terms, it's going to be plus ab. And then our last terms, positive b times negative b is going to be minus b squared. Now, notice when I add these together, my middle two terms cancel each other out. If I FOIL, my OI goes away. I'm left with just a squared minus b squared. So when I multiply together conjugates, I'm left with the difference of perfect squares. And this gets to be a very, very fast and, dare I say it, fun way of multiplying. So if I have, x plus 5 times x minus 5, oh, that's just going to be x squared minus 25. Done. Because once you've recognized that these two things are the same, my outside and the inside terms are equal and opposite. They cancel each other out. Let's do it again. Let's say I've got 3y minus 7, and I'll do 3y plus 7. 3y times 3y is 9y squared. It'd be plus 21 minus 21 is 0, and then minus 49. We're done right there. So a lot of the hard part of this is probably the pattern recognition, just recognizing that these are the same two things with opposite signs in between. But once you get used to that, 2n, and m plus 2n. Oh, that's just going to be m squared minus 4n squared. Done. Once you recognize that, this whole process goes very, very quickly. There is something else I wanted to bring up. It is a type of shortcut. It's a pattern that I want you guys to recognize. But this isn't what I would call a special form, but it is a pattern that I want folks to be aware of. And this happens when you're multiplying simple binomials. And by simple, we mean that each one has a leading coefficient of 1, or you might even say it has no leading coefficient. Now, let's just run through a couple examples, and then I'm going to show you the speed trick. So with this, let's say we've got x minus 3 and x minus 8. So I'm going to FOIL this out. X times x is x squared. My outside term is going to be minus 8x. Inside is going to be minus 3x. Minus 3 times minus 8 is plus 24. So when I do this, I've got x squared minus 11x plus 24. Now notice my first term here is just the product of these two. My last term is the product of my last two terms, minus 3 times minus 8. My middle one uses this variable, and it's just the sum. Because I'm only ever adding together my outside and inside terms, and that's just going to be use these as coefficients, this middle one is always going to be the sum of these two numbers, while this last term is going to be the product of those two numbers. So I'll write that down. Our middle coefficient, I don't know why, is the sum of our last two numbers. And the constant is the product. So when you start to see that pattern, multiplying gets to be something that you can do very quickly. Say I've got something like, y minus 2 and y plus 10. Okay. Rather than do this full FOIL and say, okay, y squared plus 10 minus 2, I could just say, add those together. That's going to be plus 8y minus 20. Now let's do it again. Let's say I've got b plus 11 and b plus 5. Okay. B squared, sum of those two is going to be 16b. Product of those two is 55. I can almost hear some people getting their minds blown. And other people might be just going, yeah, and we saw this pattern before. But this is kind of cool. This allows you to multiply very, very quickly. And spotting this pattern of this is the product, this is the sum, is going to be very helpful to us later on when we're starting to factor. Alrighty, that's all I've got for now. I will see you in the next video.